So in starting this question, the first thing that I would do is notice that I have parentheses. So when I have parentheses, again, they're always understood to be around the argument, if not explicitly stated. But those parentheses tell us that I have an inner function and I need to use my chain rule. So we take the derivative of the outer. The derivative of sine is cosine. Keep the inner fixed. And then multiply by the derivative of the inner. Now in this case, our inner function is the square root of 2x. And we know anytime we have a square root, we want to rewrite that. So really we're going to be rewriting it as 2x to the 1/2 power, and that's what we want to take the derivative of. So when we look at that, it has the structure of parentheses to a number. And whenever you have parentheses to a number, you're going to use your general power rule. So to take the derivative of the inner, we go off to the side here and we think just about the derivative of the inner for a moment. We will have 1/2 times 2x, subtract 1, get negative 1/2, and then multiply by the derivative of the inside, and the derivative of 2x is simply 2. All right, so remember that usually something before and after the parentheses is going to simplify. So here you have a 2 in the numerator, 2 in the denominator, so those will cross out. All right, so we are getting that the derivative of the inner function is just 2x to the negative 1/2. Now, that is being multiplied by the derivative of the outer, which is our cosine square root of 2x. So remember, we want to put the trig function at the end. In this case, there's multiple ways that you could rewrite it. You could write this as, and remember this is y prime, y prime. You could write this as 2x to the negative 1/2 cosine square root 2x. Or I would kind of lean towards putting the negative exponent down in the denominator. So cosine square root of 2x over 2x quantity raised to the 1/2, and of course that could also be written as a square root. So either of those three formulations, this one, or this one, all of these are perfectly acceptable for finding or for writing your derivative's final answer.